Today we're going to be talking about section 2.8, which is on graphing linear inequalities in two variables. Our goal is to graph linear inequalities in these two variables, and we're going to usually use x and y. Linear equality in two variables can be written in one of these following forms. Notice, instead of an equation, we have an inequality, which means we're going to have a less than, greater than, or less than or equal to, or greater than or equal to sign. And when we talk about the solution, basically that's going to be an ordered pair that makes it a true statement when you plug them in. So you plug it in, makes it a true statement. If it makes it a true statement, it's a solution. If it doesn't, then it wouldn't be a solution. So for example 1, that's what we're going to do. We're going to take these ordered pairs and we're going to plug them in to see which one is the solution. So here's my x, here's my y, so we plug it in. We're going to have 5 times 0 minus 2 times negative 3 is less than or equal to 6. So if we do that, we're going to get 0 plus 6 is less than or equal to 6. Is 6 less than or equal to 6? The answer is yes. So that one works. Now, let's try the next one just to see if that one would work as well, to show you what it's going to look like if it doesn't work. So here we're going to have 25 minus 10 is less than or equal to 6, and we're going to get 15 is less than or equal to 6. Is 15 less than or equal to 6? Nope, it's not, so therefore it's not a solution. And if we did C and D, we'd find the same thing. So A is the solution to example 1. So go ahead and do the guided practice question number 1. You can pause the video and hit play when you're ready to move on. So if we look at the guided practice questions 1 through 4, number 1 was not a solution, number 2 and 3 both were solutions, and then number 4, that ordered pair, is not a solution. So the next thing we're going to talk about is graphing a linear inequality. Well, this is just like graphing a line, only now we're going to have one or two things a little bit different. We're going to graph an inequality. So first step, we're going to graph the boundary line of the inequality. So we're going to pretend that this is an equation, sort of. Use a dashed line for less than or greater than. So that means if it's on a dashed line, your solution will not be on the line. And a solid line for less than or equal to or greater than or equal to. So a solid line would mean any point on that line is a solution. Just like when we have the open circle and the filled in circles when we did our inequalities earlier. Step 2 says we're going to test a point not on the boundary line to determine whether it's a solution of the inequality. If it is a solution, you're going to shade the half plane containing the point. If it's not a solution, you shade the other side. So when we talk about the graph, it's the set of all points in a coordinate plane that represents solutions of the inequality. And then the half plane is the two regions in which the boundary line of an inequality divides the half plane. So if we put just a random dotted line through here, and we shade everything like this, that is what our graph would be. So the solution is going to be every set of points, or every ordered pair in the solution to this system. So in example 2, what we're going to do is we're going to graph this linear inequality with one variable. And it says x is less than or equal to 5. So really what I want to do to start with is look at how would I graph this line if it was x equals 5. And to do that, my graph got cut off here. So we know that it's going to be a vertical line through 5. All right, and now notice here that it's less than or equal to, so we know it's a solid line. And then now we have to pick a test point. Well, the easiest point I'm always going to put is 0, 0. And I'm going to see if that's true. And I plug in x is 0. So 0 is less than or equal to 5. Is that true? Is 0 less than or equal to 5? Yes. So then we shade everything on that side. Okay, so you plug in the test point. If it's true, you shade everything on that side. If it's not true, you shade everything on the other side. So our graph, or our solution in this problem, is everything including that vertical line and to the left. So any ordered pair that we pick over here For example, that one, negative 4, 4, that's a solution. 0, negative 2, that would be a solution. It's in that shaded area. It's in that half plane. So in example 3, we're going to graph a linear inequality with 2 variables. So once again, we're going to graph this 3x minus 4y is greater than 12. So we're going to graph that line. And then we're going to go ahead and figure out where that shaded area is. Now, if we notice this, it's a greater than, not greater than equal to, so we know it's going to be a dotted line. Well, you can do this in one of two ways. You can find the x-intercept and the y-intercept, or you can turn it into slope-intercept form. Well, I'm going to use the x and y-intercepts and using the cover-up method. So I know that if I cover that up, the x-intercept is 4. 12 divided by 3 is 4. If I find the y-intercept, cover that up, I'm going to have negative 3. All right, so now I know that the x-intercept is 4. The y-intercept is negative 3. I'm going to draw my dotted line. Because I know that it's not equal to, so it's going to be a dotted line. So any point on that line is not a solution in this case. And then I'm going to pick my test point. Well, I'm going to put, again, 0, 0. So that's the test point. You'll always see me put an X on the graph because that way I know where my test point was. So I put it in. 3 times 0 is 0. Negative 4 times 0 is 0. Is 0 greater than 12? No, 0 is not greater than 12. So it's not a solution, the test point, so I shade on the other side of it. So everything below that line is going to be our solution. All right, so we have questions 5 through 10 in the guided practice. I'm going to go ahead and do all of those. If you want to pick a couple of them to try, go ahead and pick a couple of them. But at this point, you can pause video and hit play when you're ready to move on. And here are the answers for guided practice questions 5 through 10. So notice 5, 8, 9, and 10 are all dotted lines because they're just less than or greater than. Neither of them have, or none of those have the equal to. 6 and 7 are solid lines because they have the equal to sign. Number 9, I went by 3s. You can see I changed the scale there, so I went by 3s on my scale to change that so it didn't go off the graph so far. The last thing we're going to look at, the last couple things here, example 4 is a real life situation. So we're going to solve a multi-step problem that says you have 2 summer jobs, one that pays $9 an hour and another that pays $12 an hour. You would like to earn at least $240 a week. Write an inequality describing the possible amounts you can schedule at both jobs. So then it says graph the inequality and identify 3 possible solutions of the inequality. So first of all, we make $9 at job X and $12 at job Y, and we want to make at least 240. So at least means that much or more, so that has to be whatever we work has to be greater than or equal to $240. So when we do this, we're going to want to graph this. To find it, it's in standard form, so I'm going to find the x-intercept and the y-intercept. So if we find the x-intercept, it's 240 divided by 9, which is 27 point about 9. And if we take 240 divided by 12, find the y-intercept, that's going to give us 20. So what we're going to need to do now is graph this. And I'm going to draw this as this is in quadrant 1. So the origin is right down here in the bottom left. That's 0, 0. And I'm going to go by probably 1 across this. So this is going to be 2, 4, 6, 8, 10, 12, 20, 24, 26. And the same thing is going to go up the top. So 1, 2, 3, I'm going to go 4. All right. So now what we need to do is we need to put our points on here. So the x-intercept is 27.9, so about 28. So we need to go just past there. So we're going to say 27.9 is right about there. And my y-intercept is 20. So we're going to go there. And now we're going to draw our line from there to that point. And now we're going to find our test point. Well, we know that our test point at 0, 0 is the easiest one to use. Put in 0, we get 0 is greater than or equal to 240. Is that true? Is 0 bigger than 240? Well, obviously not. So my shaded area is going to be anything above this line. So our solution is going to be any of the ordered pairs above that line. So what we need to do now is identify 3 possible solutions. Well, all you have to do is pick a point. Well, I know that this point right here, that's in my shaded area. So what does that mean? Well, if we look over here, this is 6, 19. So 6, 19, that's the ordered pair 6, 19, which means we worked 6 hours at job X and 19 hours at job Y. Okay, so there's one of your answers. Now it asks us for 3 of them. So let's pick another one. And we can pick one, let's pick one right there. Well, what is that one going to be? Well, that's the ordered pair 26, 4. That means I work 26 hours at job X and 4 hours at job Y. Well, that gives me a total of 30 hours, where the other one gave me only 25 hours. So because we made more at the other job. And then you can pick another one in here somewhere that's pretty close. And it looks like that one's going to be 13, 12. Okay, so that one would be 13 hours at job X and 12 hours at job Y. So, and then when you plug those in, you'll find that every single one of those works. So if we take a point and we plug it in, that's going to, and it's a solution, it's going to be in that top shaded area, which is our half plane that works for this graph. So now down to example 5. We're going to graph an absolute value function, just like we did in section 2.7. Now we're going to graph these in section 2.8, only if we look at this, it's now going to be an inequality. So we're going to start with the same thing we did before. We're going to find the vertex. So that's going to be -2, -1. So I'm going to mark that. -2, -1. We know that the slope is -1, so that means it's going to go down 1 over 1, down 1. And then it has to go the other way as well. It has to be less than or equal to, so it's a solid line. And once again, we have to pick a test point. Well, now instead of a certain side, if it's true, we'd shade that whole area. So in this case, if it's true when we plug it in, we're going to shade the outside of the V. If it's false, we would shade the inside of the V shade. So let's put it in. We put in 0. So y is less than or equal to negative absolute value of 0 plus 2 minus 1. So 0 plus 2 is, and y is 0 as well, right? Because we're using the ordered pair 0, 0. So 0 plus 2 is 2. The absolute value of 2 is 2. So now it's going to be a -2 minus 1, which is negative 3. So 0 is less than or equal to negative 3. So is that true? Is 0 smaller than negative 3? No, it's not. So that means we're going to shade everything on the inside of that graph. So our solution will be everything inside our V. So what I would like you to do now is go ahead and go to questions 11, 12, 13, and 14. And actually, we're just going to do questions 12, 13, and 14. So go ahead and graph those three. We have three absolute value functions that are inequalities. But graph those, and you don't have to do all three of them again, but go ahead and graph a couple of those, and then you can hit play when you're ready to resume. And here are the answers for guided practice questions 12, 13, and 14. Notice in all three of these situations, the shaded area is outside of the V. That won't always be the case, as we saw in the example above. So in section 2.8, we're looking at graphing linear inequalities in two variables. So it's really not a lot different than any of the stuff that we've done before. We've graphed equations, we've graphed absolute value equations. Now we're graphing inequalities and absolute value inequality. So instead of just a line or a V as our graph, now we're going to have that line or that V, but it's going to be a half plane. Our solutions are going to be shaded areas that fall either on the outside or the inside of the V of the absolute values, or it's going to be on one half of the line. So here is your assignment for section 2.8. And again, the quiz, page 138, numbers 1 through 10, I would highly recommend that you do that. That is for quiz sections 2.7 through 2.8. So that will cover your third quiz of this chapter.